Okay, here we're going to look at an example that is in big O of n times log base 2 of n. So you remember merge sort. So merge sort, what we did is we split our list into halves. We called merge sort on each half, and then we merged it back together. And remember, when we merged things back together, we had to touch every element once. So if we had n elements, that merge operation would take n steps. And if we looked at the whole big picture, that last slide was just one recursive call. But if we look at the big picture, if we start off with the full list at the top, we split, eventually we get down to single elements. And that's where we backtrack through the recursion, we return, then we merge, we return, we merge, we return, we merge, until we get to a final sorted list. And again, that merge step was always taking in two sorted lists, and it was able to merge it in O of n time. Okay, so here's a solution to merge sort in Java, and I want you to try and write the recurrence relationship for it. So go through line by line and see what is that going to contribute to the recurrence relationship. So pause it here. Okay, so first piece is that base case. If the input is size 1, it's going to take just one step. Okay, then my next line where I'm splitting, I had to walk through my list till about halfway. So if my input size was n, that was going to take me n over 2 steps to split it, because I had to walk through to the halfway point of my list. Okay, now second half and this are both of length n divided by 2, and I'm going to call merge sort on the second half. So that's going to make a recursive call where the size is divided by 2. So that's a t of n divided by 2. Similarly, this dot merge sort, this is half as big as it used to be. So that's going to be a recursive call where n is half as big. And then last is that merge step. That's going to merge two sorted lists. And when we merge two sorted lists, we could use that algorithm where we touched each element just once. So that was going to take n steps. So I've got my base case up at the top, t of 1 is equal to 1. And for these later ones, I can say, well, with a recursive call of size n, I have to do all of those things in sequence. So I'm going to get t of n is n divided by 2 plus t of n divided by 2 plus another t of n divided by 2 plus n. So we get two copies of the recursive call, t of n divided by 2. That piece is representing those recursive calls, and we make two recursive calls. And then we've got 3n over 2, but that 3 over 2, that constant factor, when we unroll it, won't matter. It'll just lead to a constant factor bigger. And so we can rewrite that bottom recurrence relationship as t of n is equal to n plus 2 times t of n divided by 2.